All right, let's talk about something that is an absolutely essential skill for any Java developer who wants to build code that actually survives out in the wild. I'm talking about exception handling. This is the secret sauce to writing robust, crash-proof code, and we're going to break it all down, starting with the feeling I bet every single one of us knows all too well. You know the feeling, right? You've been coding for hours, you think you've got it all perfect, you hit run, and poof, it's gone. The whole program just dies, spitting out a wall of red text that looks super intimidating. It is so frustrating. But look, it happens to everyone. The good news? Java gives us some really powerful tools to stop this from happening. So let's dive into our first section and get one thing straight right away. Errors happen. It's a fact of life, even in the absolute best code. So the real goal isn't to write code that never has a problem, because that's impossible. The goal is to write code that knows how to fail gracefully. And to do that, we have to understand what we're really up against. And that right there is what exception handling is all about. It's not just a suggestion, it's a formal mechanism, like a safety net that's literally built into the Java language. It lets us spot these runtime errors as they happen, handle them in a controlled way, and let our program recover and keep going, instead of just, well, giving up. Take a look at this. It's a perfect and kind of scary example. Just one single line of code, trying to divide a number by 0. This is a classic runtime error called an arithmetic exception. And believe it or not, without exception handling, this one tiny line is more than enough to bring your entire application to a screeching halt. Now, it's really important to know that not all errors are the same. You've got your compile time errors, syntax mistakes your IDE yells at you about. Then there are logical errors where the code runs just fine, but whoops, it gives you the wrong answer. Our focus today is squarely on that middle category, runtime errors. These are the unexpected gremlins that pop up while your program is running, and they are exactly what exception handling was designed to tame. So here's what's actually going on behind the scenes. When one of these runtime errors pops up, Java creates something called an exception. You can think of it like an emergency flare. It's this special object that signals, hey, something totally unexpected just happened, and the normal flow of this program has been disrupted. And these exceptions pretty much come in two main flavors. On one side, you have checked exceptions. The Java compiler is actually smart enough to know that certain things are risky, like trying to read a file that might not be there. So it forces you, at compile time, to deal with that possibility. Then on the other side, you've got unchecked exceptions. These are the surprises that happen at runtime, often because of a bug, like the division by 0 we saw. The compiler won't force you to handle them, but you really, really should. Okay, enough about the problem, right? Let's start building the solution. We're going to start putting together our exception handling toolkit, and we'll begin with the most fundamental tool of all, your first and most important safety net. And here it is, the famous try-catch block. The concept is so elegant and simple. You take any code that feels a little bit risky, a little dangerous, and you wrap it inside the try block. If something goes wrong in there, if an exception gets thrown, your program doesn't crash. Nope. Instead, the program's control immediately jumps over to the catch block, where you get to decide exactly how to handle the situation. But wait, what if you have some cleanup code that has to run no matter what? I'm talking about things like closing a network connection or a file stream. You need that to happen whether an error occurred or not. That's where the finally block is your hero. Any code you put inside finally is absolutely guaranteed to run after the try-catch is done. It's the perfect spot for all your essential cleanup duties. So up to this point, we've kind of been playing defense, right? We've been passively catching errors that Java throws our way. But what if we want to go on offense? What if our own application logic detects the problem and we need to be the ones to sound the alarm? This is where the throw keyword becomes your new best friend. It lets you, the programmer, say, wait a minute, something's not right here, and then manually create and launch your very own exception. You're no longer just reacting to problems, you're actively signaling them. You're taking control. And just look how easy it is to do. It's a single line of code. Use the throw keyword, you create a new exception object of any type you need, and you can even pass in your own custom error message. This is so powerful for making your error logs clear, specific, and actually helpful. Okay, now this next bit is a classic point of confusion for so many developers, so let's clear it up once and for all. Throw versus throws. Throw with no S is the action. It's the verb. It's you inside a method actually launching that exception into the air. Throws with the S is a declaration. It's like a warning sign you put on your method signature. It tells any other piece of code that calls this method, hey, just a heads up, this method might throw this kind of exception, so you better be ready to catch it. And for the final, ultimate level of control, you can even create your own custom exception types. It's pretty straightforward. You just extend Java's main exception class. This lets you create super specific errors that perfectly describe what's wrong in your application, like a user not found exception or an invalid payment exception. This makes your code so much cleaner and way more expressive. Whew, okay. We've looked at a lot of different keywords and concepts. So now let's take a step back, zoom out, and see how all these pieces fit together into the big picture. Let's look at the exception family tree. This hierarchy diagram is just fantastic for understanding everything. Right at the very top, you have the throwable class. This is the granddaddy of everything that can be thrown or caught in Java. From there, it splits into two big branches. On one side, you have error. These are for catastrophic, system-level problems like running out of memory. You generally don't and shouldn't try to catch these. But on the other side, that's our world. That's the exception branch. And that's where all the recoverable, application-level errors we've been talking about live. All right, let's wrap this up. We're going to bring it all home by summarizing the key tools that we have just added to our developer toolkit today. Think of these as the essential gear you need to go out and write some seriously resilient code. This right here is your cheat sheet. Your try block is the danger zone where you put risky code. Your catch block is the safety net that swoops in to handle the failure. Finally is the reliable cleanup crew that always shows up to work. Throw is your flare gun to signal that there's trouble, and throws is the warning sign you post on your methods. If you can master these 5 keywords, you've pretty much mastered the core of Java exception handling. You know, at the end of the day, handling exceptions isn't just about preventing crashes. It's a design philosophy. It's about being thoughtful and building software that's tough and resilient. So the next time you sit down to write some code, don't just think about the happy path. Ask yourself, what could go wrong here? And then use these tools to build a program that's ready for anything. That's what separates a good developer from a truly great one.